Okay, sure. So this is your practice session for the numericals. First of all, we will be taking the 1 marks question. So 1 marks questions mainly consist of the direct applications of the formulas, or you can say the direct formula itself. Okay, so we should learn and remember all those formulas. First of all, mm, it may be asked what is the form factor of the sinusoidal waveform, and if the options are given, you should be in position to identify this. Okay, for example, this form factor of the sinusoidal waveform is E RMS upon E average, and it is the B option. Similarly, the peak factor for the sinusoidal waveform is E max upon E RMS. Okay, so uh, next is the average value of the current for half cycle of sinusoidal wave is 2 Im by pi, and the RMS value of the current for half cycle of sinusoidal wave is Im by root 2. Okay, so these are direct formulas which is being asked in the 1 marks question, but the questions can be of the form that, okay, that Im is given. Suppose Im is given as 2 root 2 amperes, then calculate the RMS value. If the maximum value Im is given as say 2 root 2, then you should be in position to apply the formula, this Im by root 2, to get the desired result, and you should be in position to identify from the options given. Okay, next thing which is to be kept in mind in this is that here we are talking about the sinusoidal wave for current, but in actual practice it could be voltage or EMF. Okay, so this is to be kept in mind, and next thing is to be kept in mind that we are here talking about the half cycle. Okay, if we are talking about the full cycle, you should mark 0, because the average value of the half cycle is 0. Okay, so you should be very much aware and notice that what is being asked. Okay, so next is the 2 marks question. So in the 2 marks question, sometimes it is asked, and then AC voltage of 50 hertz has the peak value of 220 volts. So when we talk of the peak value or maximum value is all the same. Okay, so you should be in position to attempt these sort of questions. So next is the write down the expression for the instantaneous value of this voltage. Okay, so the instantaneous value of the voltage is Vm sine omega t, which is Vm sine 2 pi ft, and Vm is given 220 volts, so it becomes 220 sine 314 t. Okay, so what is to be kept in mind here, that the frequency given is 50 hertz. First thing is this: if in some problem frequency is not given, then you are required to assume the frequency as 50 hertz only. Okay, and then you can apply this formula to get the result. Okay, so if you write 220 sine omega t, that is also good enough. If you write 220 sine 2 pi ft, that is also good enough. Or if you are writing the precise value 220 sine 314 t, that is the best result. Okay, so what is to be kept in mind here, that instantaneous value is being asked. So instantaneous value is represented by small letter. Okay, as shown here. Okay, so this is to be kept in mind. So next question is, find the average value of the current from the waveform shown. Okay, so find the average value of the current waveform shown. So here the tricky part is that the half cycle or full cycle is not given. It is not given that whether we have to calculate the average value for the full cycle or half cycle. Okay, so the average value of the current is what? 2 Im by pi, as we have done in this C part of the objective type also. But this is for the half cycle, isn't it? 2 Im by pi. So Im is here 10 amperes. Okay, so it should be 2 into 10 upon pi. Okay, but if we go by the formula, but the second half cycle is giving no result. Okay, so if we consider the full cycle, it becomes 2 into 2 Im by pi is the result which we get. But when we have calculated this result, we have divided by pi, because we were considering only the half cycle. Here we are calculating for full cycle, so we are dividing it by 2 pi. So 2 and 2 get cancelled, so we get the value Im by pi, or 3.183 amperes. Okay, again, what is to be kept in mind here, the units. Okay, the unit is a ampere. It is denoted by the symbol a. We have studied the symbols in the lab as well, so it is to be kept in mind. Okay, so, and if at all you have the any confusion that we are required to calculate the average value for the full or half, it is better that you calculate for both. Okay, so that there is no confusion. Okay, next question is, a 100 ohm resistance is carrying a sinusoidal current given by 3 cos omega t. Okay, so determine the instantaneous power taken by resistance, and second is the average power. Okay, these two are its parts which we are to do. Okay, so what is happening here? Instantaneous power. What is the formula of instantaneous power? It is the product of the
small v,
instantaneous. Yes.
the small v into small I.
Yes, small v into small I, or the product of the instantaneous voltage and instantaneous current. Okay. A 100 ohm resistance is given. So P is equal to VI and V is equal to IR. Resistance is given 300 ohm, 100 ohms, and current is given as 3 cos omega t. So 3 cos omega t is written here, and again it is multiplied by the I, which is 3 cos omega t. So when we solve this, we get 900 cos square omega t. Okay, so this is our instantaneous value of the power. Either we can write this, or we can use the formula of cos 2 theta. Okay, cos 2 theta, you know, is 2 cos square theta minus 1. So we can apply this for that formula as well to get the result. Okay, so this is the value. Actually, this is the expression for the instantaneous power. Okay, so when we are writing the expression of any physical quantity, we may avoid writing the units. Okay, but if we are required to calculate the absolute values at that moment, at that point, units mentioned is mandatory. Okay, so its next part was to calculate the average power. Okay, so instantaneous power is known to us. Load is resistive load, and we are required to calculate the average power. So for this, either we should know the formula for the average power, this is one thing, or we should go by the derivation. Okay, so if we go by derivation, what we know that this instantaneous power is having two components. One is this constant power, and second is its sinusoidal quantity. And the average power of the sinusoidal quantity is 0, so it will not play any part. So the average power is 450 watts. Okay, so this is one way of doing this. Second is what we have calculated we have derived the formula for the average power. What we have derived in the formula, the average power formula, Vi cos phi. So but since it is a resistive load, so in the resistive load, voltage and current are in phase. So when they are in phase, it means that the angle between them is 0. Okay, so phi is 0. So when phi is 0, so this cos phi becomes 1. So we can neglect this part. Okay, so now we are left with V and I. So these V and I are the RMS values. Okay, when we are calculating the average value of the power, so these V and I are RMS values, therefore they are depicted by capital letters. Okay, so if it is comfortable to you, you can write VI, but if you think that it is going to disturb you, or you cannot remember for long, you can write subscript VRMS IRMS. Okay, or you can also write VRIR. It it depends upon your convenience. Okay, so if we are talking about VRMS IRMS, then we can use VM by root 2, IM by root 2. So this is the instantaneous value of the current, which is Im sin omega t or Im guys cos omega t. So its value is 3. Okay. So this Im can be replaced by 3, and what is instantaneous value of the voltage? IR say, so 100 into 3, it becomes 300 cos omega t. So this is the instantaneous value of the voltage. So this is the instantaneous value of voltage. And what is the formula of instantaneous value? Vm sin omega t or cos omega t, both are same or interchangeable. Okay. So this is the maximum value of voltage. Okay, 300. So we can substitute this here. So 300 into 3 becomes 900, and when we divide by 2, it becomes 450. Okay, watts. Okay, here writing of units is mandatory. Okay, this is to be kept in mind. So what you can do, either you can write the capital letter W, or you can write watts is how much power is represented by a circuit in which voltage and current equations are given here. Okay, okay, so the voltage equation is given and current equation is given. So we are talking of voltage equation. So voltage and EMF are sometimes used synonymically. Okay, because you know the difference between the voltage and the current, as we have studied in our previous unit as well, that if there is no drop from the voltage source, or you can say energy source, to the load. Okay, so whatever is generated, it is appearing across the load, then we can say that the EMF and the voltage are same. Okay, if some drop is there, then we can say that okay, EMF generated is this and voltage which is reached to the load is this. Then we can differentiate, else it is used synonymically in the numericals as well as given here. So how much power is represented by a circuit? Okay, so in this question it is not given. So how the questions are tricked, I am emphasizing on that. We are here given only the power, that okay, calculate the power. But in the power triangle as well, we have studied yesterday as well, There are many types of powers. There is instantaneous power denoted by small letter p. There is average power that is denoted by capital letter P. It can be reactive power, it can be apparent power. So we are having four options. Okay. So what we have to calculate? We may get confused. Okay. So if at all in the numerical it is not given which power is to be calculated, always you have to calculate the average power. Okay, because average power is the true power or the real power, and it is given in watts. Okay, because how you can remember this thing? Because whenever we purchase any load, electrical load from the market, say it is a fan or tube light or bulb, etc., whatever it may be, what we say, just please give me 40-watt tube light, okay, or 60-watt bulb. Okay, so we mention the wattage, isn't it? So but from yesterday's discussion we know that the watt or the power, watt is the unit of the power. In general, in the lower classes also we have studied, okay, what is the unit of the power? We always say watt. Okay, that is good enough for lower classes. But now we have studied that there are so many types of power. So but the popular is this watt only. So we are required to calculate the average power only. Okay, this thing is clear. Okay, so and instantaneous power, whenever we are required to calculate the average power, instantaneous power automatically comes into the picture. Okay, so we automatically calculate that, so that is not a problem. So now it is clear that we are required to calculate the average power. Okay, so this is the instantaneous power equation, Vi or Ei. Instantaneous values of voltages and current, or EMF and current, is given. We have written here and multiplied here, and what we have achieved, we have on multiplication we have achieved 6800 sine square 314t. Okay, so this is the instantaneous power. So as I have mentioned in the previous numerical as well, that the sine square theta and the cos square theta can be represented as the cos 2 theta formula. Cos 2 theta is equal to 2 cos square theta minus 1, or 1 minus 2 sine square theta, isn't it? So it is known to you. So this sine square theta is calculated in terms of the cos 2 theta. Okay, so this is the result which we have achieved, 3400 bracket, and within the brackets it is 1 minus cos 2 theta. Okay, so again we can see that either we can apply the formula for the average power, or we can simply observe that it is having two components. One component is trigonometric quantity and other is constant quantity, and the average value of the sinusoidal quantity over the whole cycle. Okay, here we are talking of the whole cycle. Okay, so it becomes 0. So we are left with this 3400 only. So we can apply this, or what we can do, we can apply the formula for the average power. Okay, since the sine omega t part is common in both the voltage or EMF or and current, so we can say that there is no phase difference between the voltage and the current. So it is, this voltage is applied to the resistive load. Okay, so it is applied to the resistive load. Sometimes it does happen that it is not given in the numerical that it is resistive load or inductive load or capacitive load. We have to interpret from the values given. Okay, so this is the resistive load. So this phi angle is 0. So when phi angle is 0, so this cos phi becomes 1. So we are left with Vi, where it is Vrms Irms. So this Vrms Irms is can be substituted by this formula, Vm by root 2 and Im by root 2, and it becomes root 2. Root 2 becomes 2. So this is the Vm or em, whatever it may be, and this is the im. So when these values are substituted here, we get the average power like this. Okay, clear? Now it is clear to everyone. So everyone please take a note of that how we can identify the nature of the load. So if this numerical was having, say, RL load, then this instantaneous current would have expression like this. Okay, because in the RL load, the current is lagging by, say, any phi angle. And if at all this numerical was having RC load, okay, then this current would be leading by phi angle. Okay, so we should observe the expressions and identify. Okay, we should be smart enough to do this. And in case of the pure inductive load and capacitive load, you know, if we are having pure inductive load, what happens? Current lags by 90 degrees, isn't it? Okay, and in capacitive load it leads by 90 degrees. Okay, so we should be in position to identify this. Okay,